Hey everyone, today I'm going to do a video on Grasshopper. This is another part of the tutorial. Instead of doing the normal, just going over a certain aspect of Grasshopper, we're actually going to dive straight into a facade. Now I've decided this because it's a very important part of just diving straight into modeling. I think as a Grasshopper learner, we need to experience new commands and new scenarios that we haven't experienced outside of the lesson board. So a way to do that is we're going to do we're going to do a facade. It's called the Al Dubai kind of responsive facade. It's based off of the sunlight, so I'm going to show you guys that real quick. As you can see, we're looking at this facade, and this opens up where the sunlight can come in, and this covers up where the sunlight can't come in, and so on and so forth. So it's a very interesting project, and I don't think it'll be too hard, and I want to do this together to understand it and go forward with it. If we look at this, so the first thing I do when I model in Grasshopper, like always, is I analyze what I have to do. So if I'm recreating a facade, I definitely analyze the facade, kind of bring it down. What I do is I kind of bring it down to a basic shape. I really try to understand how the facade was created in Grasshopper. Not physically created, but just in Grasshopper how it's created. So we look at this and we're like, okay, how is this really created? So if we look at it, I can kind of break it down into these triangles. It's very obvious. These very arrayed triangles. Even like, let's say, this one right here. That's a triangle. That's a triangle. But then we look at the bigger picture. We kind of zoom out a little bit. And we see this triangle. This type of triangle right here. Now instead of that triangle, we can see that if we even zoom out even further and think about it, I try to find some sort of gridding structure, some sort of basic kind of grid shape that I could base off of. And I noticed this hexagon right here. And it's an interesting shape. So this shape will create that facade, as you see. So we know there's a hexagon, and then there's another hexagon. So we know it's basically, if we think about it, it's a hexagonal grid. It's a hexagonal grid that's subdivided into these triangles in order to make the facade. So that's kind of how I sum up the conclusion. And then we can worry about how it opens up later. And I'll explain. I kind of have an idea on how that's going to work, so I will do that. But we're going to keep referencing this throughout the entire series, or throughout the entire part. So let's zoom in a little bit. So the first thing I'm going to start with is a gridding. So I'm going to do a hexagonal gridding. Oh, by the way, if my Rhino looks a little different, it is Rhino 6, so the new beta version. So there's nothing really different about it. I'm just letting you guys know if it does look a little different. So for you guys wondering, it is 6, just in case you didn't see this for some reason. So, anyways, let's do square also, because I want to compare these two. So if we look at it, we have hexagonal and square. And this square they look very similar. As you can see, plane size, extent x, extent y, plane size. They have the exact same of inputs and the exact same of outputs. It's basically the same thing. This one grids squares versus this one grids hexagons. So they're not different at all. It's just they're different shapes. So if we do that, we can see that it outputs cells and points. The cells is the line work, the grid outline as we know, and the points is these points that intersect. So we want to explode all this so we can kind of extract those the geometry of this. So I'm going to do explode, connect this, and understand it. So once we explode it, we're going to now look at, we want to extract these points, like I said. So these type of points right here, these 6 points that are surrounding the entire thing. So once you do that, it has segments and then the vertices. Now the segments is the line work. As you can see, it says something about base curve, and this one is explode segments, which is the vertices right here. So, and if we look at the point, we remember that the point is our center. So we can actually type in point, click enter, and connect it to here, and we can see that's the center point. Awesome. Pretty cool. So what we're going to do now is we're going to do the segments and vertices, and we're going to actually do a list item in order to capture each one of these points into their own list. So we should have at the end 6 lists. 1, 2, 3, 4, 5, 6. So let's do that real quick. Let's do a list item. As you can see, we have a list item here. And we know that if we throw in a panel, you're probably wondering how we're going to pick the numbers out, right? There's no way we would know each number, or like what numbers will correspond with each point, but without just randomly guessing. So you're correct on that. We wouldn't know it without just randomly guessing. So I can kind of understand that this point would be 0, and I can tell by this being 1, 0. So I know this is my starting point, 0. Whether it goes this way or this way, we can figure out. So I'm going to zoom in on 1 without the kind of gridding here. I don't know why it has that. But as you can see, now if it did go down, it would be a negative number. If it went up, the y value would be a positive number. So if we look at that second point right here, or that second kind of part in this branch, we know it says 0.5, that's positive, and then 0.866, which is also positive. So we know that it has to go 0.5 and then 866. So it has to be positive. There's no way it can go downwards because this is not a negative number. So knowing that, we know that the list is adding 1 each time. So the list value, how it works, if you looked back at the list manipulation tutorial that I taught, there was the list item, and that retrieves specific things like this from a branch. So if I typed in 0 into here, for example, this is already set at 0. If I typed in 0, it would get this 0 value, which is this. So all I need to do is keep adding 1 to this 0, because 0 plus 1 is 1, 1 plus 1 is 2, and then so on, and then 3, 4, 5, and then 6. So I can actually start an addition function. Now, yes, you can just type in 1 and then do a list item. Let me do it, list item. And then plug it into here. But this is more of an automated way, and it's a little bit easier in my opinion. So let me type in 1 again. So this one is 0, as we know. So we can actually put 0 in here into the index. And then we're doing 0 plus 1, which will be a result of 1. Awesome. And then we just plug into the index. As you can see, it's capturing that second point. So now we can do that again. So we can just do a list item, and we can copy and then paste this because we know we need 6. So 4, 5, 6. Awesome. So we have 6 items now. So now we can do another addition factor. And let me just move these down here. So we can now do an addition factor again. We can plug these all into the list. So we can plug them 1. We can plug this one into here. We can plug this one into here. And then we can plug this one into here. So now we have these all. But right now they're all set at 0, as you can see. 0, 0, 0, and 0. Right? Oh, it's kind of under there. So. And 0. Okay, cool. So if we look at this, we know that this equals 1. So we know we need to just add 1 more. So we can just do the result plus 1. So result plus 1 will equal 2. So if we do another addition, we know that the result plus 1 will be 3. This kind of saves a little bit of effort from typing in a bunch of number sliders. That's just me. I like doing it this way. So we know that this 2 wants to go into this one. So we plug that into here. And the reason why I plug the 2 in because I know this one's 0, this one is 1, and this one is 2. And then now I'm going to make this one 3. And then addition 4. As you can see, it's freaking out because there's nothing to add. So we're going to plug into that, 3 plus 1, and then 4 plus 1. So we now have these. Let me straighten these out. Oh, wait, no. Let me straighten these out. So let me go over what I just did. So what I did was, I just did an addition factor and did 0. Because we know this number needs to be, this number needs to be 0. This number needs to be 1. This number needs to be 2. This number needs to be 3. This one needs to be 4. And this one needs to be 5. Now we know that because of the panel. This one needs to be 0, 1, 2, 3, 4, 5. And we have 6. What's the 6th one? What is the 6th one? Okay, the 6th one just repeats itself. Interesting. So the 6th one just repeats itself. So that's not what I want. 1, 2, 3, 4, 5, 6. So we have 6 sides. Now, this is right now, this panel is reading right now 0 through 7, which is weird because right now it's reading 175, which is somewhat okay. That's interesting because usually it would not read this 6 point. A way to do this, if you really wanted to solve this problem, you don't need to because we have these list values in order to solve that problem. But a way to solve that would be to do a call index. And you would plug in this list, and then you would type in 6. And that will get rid of that value. Because right now, as you can see, now it's reading 0 through 5. Cool. Because this is basically reading, if you think about 0 counts as a number, it'll be 1 through 7. So it's rereading this 1 point. As you can see, it's duplicated this point 0 and 6, which it should not have done. I have no idea why it did that. It's really weird, honestly. It shouldn't have done that. But it doesn't matter because all I did was list the points out, so I don't need to do it twice. So this call index is not needed. If for the sake of completeness, if you want to do this, you can do the call index and then plug in all the list items in here. And actually, maybe I will do it. No, I won't do it. It's too much. I'm already plugged in everything into here, so actually, it won't take that long. Okay, I guess I'll plug it into here. The reason why you don't have to is because the list item, it retrieves certain items of the list. So this will be 25, and this will be 25, and this will be 25. And the reason why it's 25 is because we set our extent x and extent y to 5. And I didn't set it up like that. The extent x and the extent y was set up as default at 5. So you don't have to worry about that. And just for the sake of this, I will just type in 5 so you can understand the script better. Cool. So 5 times 5 is 25. So that's why we're getting that number. And we can actually just plug in here. So 1, 2, 3, 4, 5, and 6. So now, as you can see, we're still reading the same amount, 25. And you can see it eliminated that 1 point, which is awesome. So cool. That's all we needed. So let me move this here in front of this. All right, cool. So now once we have the list item, once we have all these points labeled out, as you can see, 2, 3, 4, 5, and 6, once we have that, we can now start to actually, if we go back to the image, draw out the geometry here. So we're actually going to draw this line and this line to make the triangle. Now you ask, well, how are we going to do that? Well, the easiest way to do it is to just do a line component. So we're just going to do a line, and we're going to start with this point and this point. So we know this point's the center, so we can go back to our line, and I'm going to make a mistake here on purpose, and I'll show you in a second why it's a mistake. We're going to use this point, and we're going to use this point, which is, as you remember, is the center. So if you highlight that, that is the center, so we're good, right? We can just plug this in, and it'll make a line, right? Not really. As you can see, I knew that was going to happen. It's going to make all this random geometry that's not going to make any sense. You might wonder why it's doing this, and I can explain it. If we look back at the center points, and we look back at this list, if we throw a panel, as you see, the panel is like one of the most useful things. It makes you understand the script. It's grafted right here. And a graft means it is each one of these points is in an individual branch. And if we look at this, right now it is not grafted. It is completely in its own group. So they grouped each center point up into its own row. So this will be row 1, this will be row 2, this will be, or if you want to read it like the list has it, row 0, row 1, row 2, row 3, and row 4. So it's not really helping us out. So what does that mean? Like, what does that even mean? Like, you're probably asking yourself, why do I care about that? You're like, okay, let's look at it. So this is 0.00, and this is 0.173. So you can see, the reason why this matters is because it keeps drawing the geometry to each other. So it'll basically keep saying to this point will have to connect to this point, and this point will have to connect to this point, and it'll keep connecting to each point. The reason why it keeps doing this is because it's grouped in lists right here, not grafted, so it's not reading independent from each other. So it'll keep drawing. When I do a line from here to here, it's not understanding that when I draw that line, it means here, it does this line. See, as you see, out of all that mess, it does do that line, but it also does more than that line. It does this point and this point to center. So this graph, or this, not graph, sorry, this list is basically saying, move this point here, move this point here, then we're going to draw a line here, then we're going to draw a line here, then we're going to draw a line here, here, and then here. So it draws a line in all 5 of these points. Then it draws a line on all 5 of these points, and it keeps going. And that's why this point draws here. It's hard to tell, but it draws here, it draws here, and it draws here. So this 0, 1 point, or 1, 0 point, let me find it. It's going to keep drawing to each one of those points. So the easiest way to fix this is just to flatten this. Or no, sorry, to graft it. Not flatten. It's to graft it. And then you can see the branch is now fixed. It's now reading 0, 0 and 1, 0. So now it's going to draw in each individual branch instead of reading it as. And the reason why, I know I already went over this, but I'm going to re-show it again. I think this will help out just seeing the 2 panels side by side. Right now it's reading, let me see if I can get this right. It's reading 0, 0 and 1, 0. So we have 0, 0, 0, which is here, and then we have 1, 0. So it's going to draw 1, 0, the 0, 0, 0. It's going to draw a point at the 0, 0, 0. It's going to draw a point at 0, 1.73, and then it's going to draw another point at 0, 3.46, and it's going to draw another point at 5, and it's going to draw another point at 6. Now, as you can see, it does that because it says that this is, it's basically saying that this right here is a starting point, and then this here is the end point. Or this is the starting point, and this is the end point. It doesn't matter which one's the starting and the end point. The factor of the result of it is that it draws 5 individual lines. So technically, if you think about it, it draws 1, 2, 3, 4, 5. If you count this, it draws 1, 2, 3, 4, 5. This line doesn't count because it has this weird geometry here. But, oops. Maybe it doesn't draw it here. But it does definitely draw 1, 2, 3, 4, 5. It does draw 5 lines. And we can actually see it. 4, 0 through 4 is 5. This is 6. So right now there's only 4 center points, or 5 center points that it's picking from, instead of 6 because there's 5 rows of them, so that makes sense. So it's only going to draw 5 lines. So 1, 2, 3, 4, 5. Yep. Okay, so it does draw those 5 lines. So it draws the 5 lines because of that. And I know that was a bit confusing, guys, and I want to really explain this. And as I said at the very beginning of this tutorial, I'm going to explain everything I do in extreme depth because I feel like if I don't explain it, you guys are just going to be lost and you guys are just going to follow me on the script. And I really want you guys to understand this and not just kind of copy what I do. And I think that's very important. That's definitely for me an important factor, and I want you guys to understand that. And I hope that made sense to you guys. If you guys want me to go over more on how listing works, I can definitely do that for you guys, and I can definitely help you guys out on that. This was a kind of a perfect example on how to understand it, because if you look at it, it kind of draws it here, draws it here, So basically, this is the start point and this is the end point, so it's going to draw a line for each one of these points. So what grafting does, grafting, which is making everything in individual branches, it's going to draw a line on each one of those. So 1, 0, or if we say this is the starting point, 0, 0, 0, right? Let's go there, 0, 0, 0 to 1, 0. So it just draws a line there, and that's the end of the branch. See, it has, this is branch 1 and this is branch 1. So it starts at the exact same place and ends at the exact same place. Starts at the exact same place and ends at the exact same place. So it makes this line geometry that we want. Awesome. So awesome. That's what I want to show you guys. So now we drew this line. Now we want to draw this line. So that was a lot of explaining. I want to make sure you guys understand this, so that's why I explained it so much in like 3 or 4 different ways. So we can just do another line component. And we have the center point, which is here, grafted. Oops, not like that. Here, grafted. And we have this point right here. So that should be the second point. Yep. And as you see, it draws this nice triangle, which is what we want. Whew. Okay. So what we can do is technically we can get this segment and join them all up and get the area of this curve and start to actually manipulate the surfaces and start actually articulating the surface that way. But I would recommend not to do that, and I would recommend to draw it the way I'm about to do it with the line work. We're basically going to start subdividing this triangle out by 1, 2, and 3. So 1, 2, 3. So we're going to start kind of dividing this triangle up. So we're going to do this point and then down to this midpoint, here to this midpoint, and here to this midpoint. So the easiest way to do that is to take these lines, do a divide curve component, and I'm going to copy and paste this, and connect these two, make a number slider for both of them to be 2, and as you can see, it's now creating the start point and the end point and that midpoint. So what we're going to do now is do a list item, and then we're going to plug in this list. And we know that if we look at throw in a panel, that this is 1, 0, 0.5, and 0, 0. So just knowing, let's say without even guessing, we know it has to be one of the 3. So we can technically just guess 0, 1, or 2, right? We don't have to really kind of try. But let's say we don't want to guess. Let's say we want to get it completely correct the first time. We can look at the panel and we can say that this has to be 1, 0. As you remember, this is 1, 0. And then we know this is 0, 0, 0. So just judging based off of that, we know that it has to be the midpoint. We want the midpoint, so it has to be here, the 0.5. I mean, it's pretty obvious, but I want to explain it that this is 0, 0, and this is 1. So we know that we want this midpoint. We already know that we want this midpoint, but we narrowed it down to just this last one. Because we know that this is the start point, this is the end point. Then we want the midpoint, so it has to be this one. So we know the line index has to be, the index has to be 1. We're going to type in 1, and we're going to plug this in. And we're going to plug this in here, and then we're going to get 1 because we know that's the same. It's coming from the same index. If we throw in a panel again, it's going to be 1. Awesome. Cool, cool, cool. Exactly what we want. So now we need to do this last segment right here. So we know this segment was in the exploded section, or in the call index if you want to go to. This one should be reading 150. This one's reading 175. Okay, so we know it's one of these segments right here. So you can see all the exploded geometry is reading as segments. So we want this segment. So we're going to do a list item, and we're going to plug this into here. And we know that, just guessing, it's 0. We click it, we got it right. It's 0. And here's why it's 0. We know this is 0, so this has to be 0 because we can kind of guess between that this line is 0 because this is the starting kind of area. So this is 0, 1, 2, 3, or 1, 2, 3, 4, 5. Understanding that, we know that I'm going to drag this all the way here. As you can see, I'm just going to drag that all the way here. We're going to straighten these out. So this is one of the lines, this is one of the lines, and this is one of the lines. In fact, I'm actually going to move it back here a little bit. We're going to do a divide curve again for the third time. And we know we want this curve. And we know it's that second one still. And then we can do another list item. We only want 2. Sorry, we only want 2 divides. And then we need to do a list item to retrieve the center point. And we know that it's 1. Because it's still reading off the same type of geometry. So if we highlight all 3 of these, we know we just got those points. So good, we got those points. That's exactly what we wanted. There's nothing that nothing that we're missing. Awesome. So what we need to do now is start to draw the geometry out. So let's do that real quick. Let's do line. And draw this point to this point, this point to this point, and this point to this point. So we know that this is one of the list items, so we can just kind of drag this here. We know we don't want this one first, so let's start with this one actually. And let's do this to the center point. So let's plug that in. Cool. So that's the first one. Let's do another line. We have this point to this point. I'm going to plug this in here. So this point to this point, sorry, this point to this point. And we're going to do number 1. And now we're going to do this point to this point. Very simple. This point to this point. Cool. So now we have these points. So now we want to get the center of this triangle. And the easiest way, we already formed that by this intersection. So the easiest way to do it is to do a CCX. It's not called that anymore on here, but it stands for curve, curve, intersection. But it's not called that, it's just called curve, curve. So we're just going to type in, but it still responds to me typing it. So CCX. So it's this curve, curve. So let's click on that. We have these lines. If you highlight them all, we have these lines. And we only need 2 as intersections, right? You only need one, this one, this one, this one, this one, or just these 2. So we're just going to randomly pick 2 lines. So this one and let's say this one. Doesn't matter. So now we got that center point. Awesome. That's exactly what we needed. So now we're going to draw also one more thing, a line between this center point and this point. So let's draw a line. Before we get started with the crazy stuff, you click this point, which is the center, and then this point, which is that division point in the list item, which is one of these. Yep, this one. Awesome. That's exactly what we wanted. And now, what we're going to do is a move command. And here's what we're going to do a move command for. If we look at this facade, we know we have this kind of line work done. So we have a lot of the line work done before we make it a kind of a solid. Sorry about that. Before we make it a solid. So we have this lines. So we have this, this, and this. Great. That's what we want. But right now, this looks like a solid triangle right here. But we want to turn it into like a kind of a responsive facade, like this kind of has it. As you can see, it kind of indents. Now, if we study it, we can see it's just this point right here, kind of moving back and forth, like this point. So if you think about it, if this was a point and we push it back, it would respond to this surface and actually kind of make it thinner. And actually start to retract and respond to a point or the sunlight. So in this case, we're going to do a divide curve real quick before we start with anything. Do the 2 again, and it's going to be the same thing. We're going to do a list item, and then we're going to do a... Do I want to do this? I don't need to do this, actually. Yeah, I don't need these points. I'm going to keep the line. I'm going to keep it here just in case. So I'm going to actually keep doing it. So this is going to be 2. Or, no, sorry. Excuse me. 1. I'm going to plug it in here. So this stuff is on the side just in case I need it. So I'm going to put this down here. This is just work for just in case. This list item is just to get that subdivision point so we can start moving around with that point. So what we're going to do is we're going to do a move. We're going to do a, let me read this, how much is points? 25 locally defined. All right, we're good. We're going to move that point. In fact, we're not going to plug that in yet at all. So we're going to focus on what to do. So we're going to actually move that point based off an attractor point. So let's actually start, oopsie, let's make that point real quick. So this is our point. No big deal. That's just our point. No big deal about that. So we made the point. And we're going to base off that attractor point. So that's going to be our reference point that we're going to use in Grasshopper, but not yet. So first we need to define the amplitude, so the amount of movement it'll make, and a vector. The vector is just a direction. So what we're going to do is just type in amplitude. Plug this in here. Now we're going to do a vector to pt. And I'm actually going to move all this stuff here. Now, an amplitude just asks for, if we're doing an attractor point, if you remember in the attractor point lesson, we did something called a remap numbers, and then we did a bounds, and then we did a closest point. We're kind of going to do similarly something to that. So let's actually do the most of it. So I'm going to do remap numbers. I'm going to plug the mapped into the amplitude, not the clipped, the mapped. And then we're going to do the a construct domain. And we're just going to create a domain real quick in here. Now ask for a source and a value. So we know that the bounds goes here. And now instead of doing a closest point, we're actually going to do man, it's not far enough away. We're actually going to do a distance. So distance. And remember with the closest point, it does also have a distance component as well. So what we're going to do is, and we remember that the distance goes in both, so we're going to plug those into both. Let me delete this. And now ask for point A and point B. So what I'm going to do is I'm going to do a point and set that point up and reference it. Cool. I'm going to plug that in. Now it's asking for point A. Point A is basically, what are we moving? So we know we want this to be moved. Awesome. So we have this kind of section done. So let's go back to this. It's asking for a vector, the base vector, so let's just plug that in. And asking for 2 points, point A and point B. So what would that be? Let's think. What would that be? Well, I'm thinking that the show direction, we want to use this center point and this point right here, right? The endpoints. So we know that one of them has to be this. Oopsie. One of them has to be this, and one of them has to be that center point. Where is it at? One of these. Yep, this one. And now we want to move this point, remember? So we're going to plug this into the geometry. So let's see what that does. As you can see, it's moving it pretty far away, but it's not moving. It's all moving pretty, uniformly. It's not moving exactly how we want it. This one's reading 25 values from a source. So let's actually flatten this real quick, and it makes this crazy geometry here, crazy type of starting bounds. So we know the domain start is here, and the domain end is here. So we know that this ends in 1. So why don't we just reverse it, and this ends in 1, and this ends in 1, and this starts with 0. So let's flip it. Doesn't seem to work. So you must need to reverse the list. Nope, not reverse, sorry. Reverse list. That doesn't seem to work either. So, that doesn't seem to work. Great. So we're going to look around, and we notice that this point right here is the 25 locally defined. So we're like, okay, that's fine. Now let's see how many outputs here. 625. What? Yeah, that's way more than 25. So we need to get that back down to 25. So right now it's probably reading them all jacked up. So this point, so I'm going to actually graph this real quick, or no, flatten, sorry. I'm actually going to flatten that point and highlight the geometry that's being moved right now. As you can see, it's moving pretty uniformly. So it is working, but it's working in the wrong direction. That's not the direction I wanted in. I want it the other direction. So let me find a way to reverse that direction. So right now it's reading this, and so right now it's reading this point and this point as the reference. Why don't we do throw in a negative? Right now it's reading 0 to 1. Why don't we read 0 to -1 instead? Because that seems like to be the reverse, right? Okay, so we're getting somewhere. So now we have this point. How much is this reading? This is still reading 625, which is not what we want. So that's already a problem. But the good news is we're getting that point out there. Awesome, right? The point is now moving in the right direction. So as you can see, the point is working. As you can see, the closer it is to the point, the closer it is to this center. And the farther it is from the point, the farther it is away from that. But I don't want it at 1. I want it at whatever this distance is. I have no idea what that distance is. So for right now, in a later tutorial, I will show you how to get this exact length. But for right now, I'm just going to show you, I'm just going to kind of ballpark it. But I don't want this domain start to be 0. I'm going to say 0.0625, which is very low number in feet. So right now the model is in feet, so we're just going to put it at that. And we go back to the closest point. It's reading that right now, and it's actually reading the opposite direction. So we have to make this negative as well. Negative. Plug this in here, and plug this in here, and cool. Now it's working. Awesome. Cool. Everything's working. Usually this never happens. So, so right now it's reading this as 1. So I don't want it to read 1 inch. That's a lot. So we're actually going to play with the number slider a little bit and see the farthest point away from it, which is right here. So that's a huge distance away. And I want it has to stay within these bounds. So I'm just going to start playing with the number slider and seeing how far I want it. The max. So this is just saying the domain and the range. The domain is basically saying this is the max value it can go out. So the max value is like 0.3. I'm going to make it whatever that is. Let's just say that for right now. Yeah, that's good enough. We can figure out the absolute distance later. Right now, we're just trying to model it. So the problem is here, it's reading 625. And I'll show you why that's bad. If we try to make a surface right now, it's basically right now duplicating points. And I know why it's doing this. And if it does do this, right now it all looks fine, right? It all looks pretty decent. And actually, let me hide this because it's confusing me. But it's all reading pretty fine. It's reading good. So when we make a surface out of those points, it's going to go crazy. And I'll show you. If you don't believe me, 4-point surface. So this is point 1. Point 2 will be here. So this is a 4-point surface. So basically, it takes 4 points before I start doing this. It takes 4 points and creates a surface. You can also do 3 points and it'll create that surface as well. So this is point 1, 2, and 3, and it'll create the surface, which is awesome. That's what we want. So point 1, point 2, which is that list value here. This one. So point 1, point 2, and then we know that 0.3 will be that CCX. And I'm going to show you that it will get completely messed up here. And this is a CCX. Yep. Watch, it's going to go crazy. Yep. It's going completely insane, as you can see. And you know why? Because it's right now, instead of reading 25 right here, it's reading 625, which is crazy. So that means it's, because right now it should be reading only 25 points. So let's scroll down until we get to 25, or 24, because technically 0 counts as a number. 24, and it's, as you can see, 0.747. Doesn't that look familiar? 4.43. Doesn't that look familiar? You're looking at it and you're like, these numbers look familiar, so let's remember this. 0.745 for a 0. 0.745. Okay, this one says 0.43. Maybe it's just a coincidence. Nope, also says 0.43. So as you can see, it's duplicating itself. So basically, there's a copy on top of a copy on top of another copy. So that's why it keeps recreating them in this gigantic fashion, which is not what we want. So let's move this panel out of the way, and let's fix the problem. Let's start to explore kind of what the problem is here. So now let's kind of dive into this. It's going to be a little complicated, but we will work through it. So 625. You're like, oh god, where do I even start, right? I don't even know where to find this problem at. So we look at it, it says 625. You're like, okay. So what I do is I hover over everything that says it. So it says 25. This says 25. This says 25. 25. 25. 25. I researched that. 25. 25. 1. And this is one domain, so it makes sense. 25. Yeah. Okay, so it's going a little insane. And we're wondering, where is that insanity coming from? So it has to be from here or from that point. So we're going to go back and trace. Could it be here? It could have gone through here. Ah, there it is. Alright, cool. We found it. So, right here. I don't know why I said that was 25. 625. Right there. So, we isolate down the 625 is coming from this component. 625. So, it has to be coming from this amplitude component. So, we're like, okay, how do I resolve this? It still says 625. If we look on the other side, it says 25. We want to keep it 25. Because if we look at it, where is it? If we go to a panel, by the way, I've used a panel a lot, so you can kind of see the usefulness in real life on how it works. As you can see, we have only just 25 components, which is what we want. If we look at this now, it's reading the same thing. It's reading that, but just a massive list. So what we need to do is basically make it look like this. So why don't we just try grafting it? I don't know. Let's see how that works. Maybe it messes it up. Nope, doesn't seem to change, right? I don't think anything changed. So, I don't think anything changed there. So, why don't we just try flattening it instead? That doesn't seem to change anything. Maybe I did the wrong component. Maybe I did this. Maybe it's not this one. It's this one, right? You're thinking it's this one because this is the one saying 625. Maybe you're right. Maybe you are. Pretty sure. So, let's try grafting it. Doesn't seem to be, because it's lagging really bad. Okay, so as you see, it didn't really work. And this reminded me, when you model something very complicated like this, you want to always save. So I am going to save document and put it under my put it under kinetic architecture, and I'm going to name it Facade Study Lesson 2.0. Don't ask why it's named 2.0. It just sounded cool. So right now it's reading like this, and I'm like, ew, it's coming from one of these. Has to be. There's no other way it's working like that, right? Has to be coming from one of these. So it could be this one, but this is reading 625 from some component. It could be this one, so I think I already did this. But we can graft it and see nothing's happening. Maybe I plugged something in wrong. No, this is still reading 25, so I want to do that. Maybe if I flatten this, you can start kind of understanding how these functions work. So if I flatten this, let's try. It's loading, so it's probably not right. If it loads a lot, it's usually, you can kind of guess it's not right. So we know that this isn't, so we don't need to see the surface for this, because we know that this is wrong. So yeah, that's 625. This one's reading 25, right? Yeah. Okay, that seemed to fix it. Let's see why that fixed it. If we look at this, values to remap, and then this mapped. It's still reading 25. Amplitude's reading 25. The vector. So we did isolate it down. So when we know this is 625, we know that this is 625. So we know it has something to do with this component. So it has to be either 50-50 here. That's this component or this component that's causing this to be 625. So let's look around. So we kind of trace it back down here. We already know that this point's right, so we can eliminate it down to just the motion. So we go back down here to the vector. Now this is 625. So I'm thinking the reason why I started flattening and started grafting this is to understand that this could be wrong, right? So, or this could, one of these may need to be flattened or grafted, because this one's 625. So it has to be something connected to this component. So I was thinking it could be the vector, right? So that's why I started flattening and grafting the vector, right? So, but that didn't work, right? As you saw, it kind of lagged my computer and didn't really work. So we have the amplitude. That's the only thing that's left, because these two, nothing worked, right? So well, that's out, right? We're gone. So amplitude. Let's look at the amplitude. We trace back down. We have these: the mapped, value, source, and target. And you see these are reading 1, 1, and this is 25. And I already flattened this one, so it can't be this one. Because right now they're all reading. Nice and dandy as flattened objects. So if we look at this, this one's not reading flattened. This one, or this one is, no, this one's reading flattened. Sorry. I'm saying that when it goes to here, it reads it as this component of 625 letters, or 625 individual components, or values, sorry. So, when I flatten this, did I graphed or fine? I cannot remember. Sorry, I grafted it. My bad. Sorry, it's a lot of talking. So when I grafted it, as you can see, it creates it all as individual branch. Nothing new. But when I create that in the individual branch, it kind of trails it back to this vector and doesn't seem to react to it. In terms of, it doesn't actually, what's it called? Right here. It doesn't actually create that 625. It treats, where is it? 0.23. It treats each one of those points that's created as one solid. So we have the 25, right? But the problem is, if we look back at the 25, we have all this. That's not what we want, right? It creates all this line work. That's not what we want. So we know that's wrong, right? So we go back to this and we look at it and like, all right, that's not right. That can't be right. Now, as you see, I am having a troubleshooting error, and I want to show my process through the troubleshooting area, and I'm trying to narrate it. I may think when I talk I look like I figured it out, but not always. So I think learning Grasshopper is a very tricky kind of way to understand something. And to see other people kind of struggle and go through the troubleshooting method really helps out in the learning process, because you can see how they learned and how they troubleshooted correctly. So we can just keep going through here. Maybe we messed up somewhere here. So this still reads 625. Not right. So let's start playing around with these points. So I don't think it's anything in the remap component. Let's see what this reads as. This reads as 25. So what happens if we flatten this? So it creates a circle. That's not what we want. Once if we flatten this, it just creates another circle. If we graph this, does it change anything? Nope. So this is kind of the educated guess. Nope, it doesn't do anything. So if you look at this, we can see that, so it has something to do with these two vectors. So let's try actually grafting this. That doesn't do anything, right? No, that's pointless. Let's try flattening this. Oh, I think it worked. So let's try unflattening this and flattening this again here. That seemed to work last time, but this is 25, so that's right. Let's make sure everything is geometry-wise correct. Seems to be. Okay. Sorry guys, sorry about that guys. So I did have it right the first time. The first time I did do a flatten here. The reason why I thought it was wrong is because this fancy wire shows that there is more than one, let me see. Let me make sure I define this correctly. Is when you have a fancy wire, it shows it as it has more than one branch. So when a fancy wire is shown, it shows it has more than one branch, which means it's grafted usually, or it's subdivided up. As you see, this panel, same thing actually. So that's why I thought this was wrong. But yeah, so I thought it may have been one of these, but I guess I was right. I guess I was right in the assumption that this part was the problem, or this part is one of these two. It technically was this one and this one, because these connect to the two. So right now we have 25, so we're good. Awesome. So we can kind of move on to the final part. So we can do that 4-point surface again, and we know it's 1, which is this one. Oh wait, sorry. 1, which is this one. 2, which is the top one. So let's find that top one, and let's actually save. All right, cool. 2, which is the top one, which is, I think, list 1. So remember, if we go back to that very list, we know that this is 1 here. Because if we click that, that's the one we want. So these lists you will go back to. So these are important. Just trust me on this. And then corner 3, which is the center CCX, we can actually go all the way back to that CCX, click on it, get the arrow, kind of drag it there, and to C. And this is still making that crazy geometry. It's not what we want. It's still reading 625. That's reading 25. Now let's see what's wrong. So we know this is reading as flattened. This is reading as, let's check it out. This is reading as grafted. So maybe the CCX needs to be flattened, because if we look at this, let me kind of drag this down, sorry, that they are reading as in 0, this is reading like the other case, so 0.5 to 1, 2, 3, 4, 5, 6, so on. So it's making, literally, from this point, it's making 25 panels from this point. So it's making this, it's using this point right here to make 25 panels. Then this point to make 25 panels, and this point to make 25 panels, and so on and so forth. So, corner C was the CCX, I remember that. So what happens if we flatten it? Doesn't seem to do anything. So let's check out corner B. Maybe that's it. Maybe corner B is it. Let's check. So we click on corner B. We hover all the way back. Corner B, sorry. Still reading that 25 value, so it can't be it. So maybe it's a list issue, which I know it's a list issue, by the way. So if we look at this, we know one of them is grafted and then one of them is flattened, so it's going to read weirdly. So why don't we actually go along with it? Sorry, unflattened. So now we have this. We know that this is the CCX panel. This is all grafted, and this panel is from this move, which is all flattened. So why don't we actually take the corner A and graft it and kind of let it go along with this and make the panel? Because if we graft it, think about it, we're going to have 0, 0.50, and they will connect. It'll just read as one branch and read as one line for the surface. So let's do that. Let's see what happens. Oh, that looks a lot better, right? So that reads a lot better. So let's take that panel and explore that real quick. And I'm actually going to do a graft tree in order to understand this component. So you see this is the before and this is the after. And as you can see now, they're reading like cohesively 1, 1, 1, 1, sorry, 1, 1, 1, 1, 1, 1, and so on. So they're reading parallel. Unlike this one, it's reading 1, 1, 1, 1, 1, and then this one, and once it gets to 24, it starts at the next one and keeps going. So 5 times this will be like 625, and that's why I was reading that. So right now, it should be reading 25 surfaces. Great. So let's make another surface, because remember, go back to our browser, we only have, right now, with that 4-point surface, all we did is create this. We just need to create the other one. So let's do that real quick. So let's do 4p surface and do this move. Let's see. We're going to start with this point. We're going to start with now this point. So it will be, let's see, that will be list 1. Oh, no, sorry, not this one. Excuse me. We're going to this one right here because we want to do 1, 2, 3. So this one, which will be 0. And then this final one, which is the CCX. And it made that crazy stuff again. And we know why, because we know corner A here was grafted. So all we need to do now is just graft it. Awesome. So now we have these surfaces. Now we have this surface. Cool. Awesome. So now we have that. Oh, well, let me organize this out a little bit. Cool. So now we want to do is join these two, because right now they're reading as 25, 25. So 25 times 2 is 50. So it's going to get a little complicated if we don't join them together as one whole thing. So we're going to do join, rep join, and we're going to connect, and that will make, oops, remember you have to hold shift in order to plug in 2 at a time, and now they should be reading as 25. Awesome. So this is 25. Awesome. So what we need to do now is take this, and we're going to do something called a polar array. Now, polar array is we're basically going to just array this around this triangle. So we're just going to rotate this type of surface geometry around this point 3 times in order to kind of create this triangle. So we're basically we're arraying it around this point. So for example, this surface right here, this surface, all we're going to do is take this point and just rotate it along this to get this one, and rotate along here to get this one. So let's do that. So polar array. So it's asking for the geometry, the plane, and count. So we're just going to do the count real quick. We'll just do 3. And we know our plane is this point. So we know that point is the CCX point. So we're going to go all the way back to our CCX and plug it right into the plane. Cool. And then now we're just going to plug in our geometry. Awesome. Now it worked. That's awesome. So it worked, right? But now we're reading 75, which is not what we want. We want to read these all as one individual piece, as one whole piece, instead of 1, 2, 3. Because 3 times 3, 6, 9, 12, 3, 6, 9, 12, 15. 15 times 5 is 75. We do the math. So, in order to do that, we're going to do another join. So we're going to do another rep join. We're going to do that. Another rep join, so they're going to read as 25 again. And now we're going to do another polar array. So that we're going to do our final polar array in order to get this geometry, or let's say, let me scroll here, this geometry along this point. Cool. Oh, nope, not what I meant to do. Actually, I'm glad I did that, so I can tell you guys why it's doing this. So, right now, the plane is reading at world XY. When it usually says that, it's reading this plane is reading at the 0, 0 point. So basically, if you look at it, every single part of this geometry is revolving around this point. As you can see, everything is literally revolving around this point. And the count is 10, so it's going to make it 10 times. So that's why usually with polar array, I always plug in the geometry last. So let's disconnect this. So count, we know we want it to be, if we look differently, look at it. 1, 2, 3, 4, 5, 6. So we know we have 6. I'm including the 1 here, so that's important. So we're going to do a count of 6. And we know we want our plane to be the center right here. So let's do that real quick. Let's do the points. And we're going to use the one that's already grafted and plug that straight into the plane. And then use the geometry. And it worked. Awesome. So that's exactly what we want. So now, as you can see, the geometry isn't really actually the geometry right now. It's reading flat. And that's not what we want. We want it to read as a solid. So in the next tutorial, I teach about this. I'm going to use this exact same file I have right here, the exact same one, nothing different, and teach you guys how to make this from this flat, look at the front view, from this flat looking one to actually more of kind of a solid and actually have some depth to it instead of reading as a flat object. Right now it's just reading as a tessellation, kind of this flat paper printout. But the interesting part now is we can take this point that we referenced in Grasshopper and actually start to move it around. And this gives us an understanding on how the point really interacts with the geometry itself. Let's see, it's starting to open up. Okay, let me highlight it. Open up. Open up here. And open up here. So as you can see, it starts to actually open up the geometry and really, you start to understand how this point is really working. So if we treat this point as the sun, we can see that it starts to open up wherever the sun kind of rotates, as you can see. So awesome. So yeah, in the next tutorial, I'll just teach you guys how to make it more like this, kind of a little bit of depth. So yeah, guys, hope you guys enjoyed this video. It's a very long one, definitely, I will agree. So thank you guys for watching. Hope you guys have a great day. Hope you guys learned something. And if you have any questions, just let me know. Leave it down below in the comments, and I'll get back with you with some answers. And try to help you guys out. And I hope you guys really learned something. And I really hope this was a helpful tutorial. So you guys, thanks for watching. Bye.